1943, Tatakawa Airfield, Japan, Lieutenant Fubashi pushes the throttle forward on the second K-84 prototype and watches the airspeed indicator climb past 387 mph, faster than any Japanese fighter has ever flown. Below him, engineers clutch stopwatches as his Hayate climbs at 2780 ft per minute, nearly matching the legendary P-51 Mustang. For the first time since Pearl Harbor, Japan believes they've built a plane to beat America's best. Two 12.7mm machine guns, two 20mm cannons, 65mm of armor glass, 2,000 horsepower of Nakajima engineering perfection. The test reports are euphoric. The prototypes are flawless. Production orders flood in for thousands of units. But 18 months later, squadron leader Kobayashi files a different kind of report. Aircraft 1446 lost on landing approach. Gear collapse. No enemy contact. Then another engine failure at $15,000 FTDA, and another brakes failed on takeoff roll. By 1945, the same design that flew flawlessly in testing could barely reach 250 miles in combat. Japan had built a plane that could beat the P-51 Mustang. They just couldn't manufacture it when it mattered most. The Nakajima Ki-84 Homare engine roared to life beneath Lieutenant Fubashi's hands as he settled into the cockpit of the second Ki-84 prototype on that blazing July morning in 1943. Through the 65mm armor glass canopy, he could see Chief Engineer Koyama standing beside the runway at Tachikawa Airfield, stopwatch gleaming in his palm like a talisman. The engineer's weathered face bore the intensity of a man who had poured 18 months of 16-hour days into this single moment. The moment Japan would prove it could build a fighter to match America's vaunted P-51 Mustang. Fubashi's gloved fingers traced the throttle quadrant with the reverence of a samurai, handling a perfectly forged blade. The Homare's 18 cylinders delivered 2,000 horsepower at takeoff, more raw power than any Japanese fighter had ever possessed. As he advanced the throttle, the aircraft strained against its wheel brakes like a caged predator sensing freedom. The sound was intoxicating, a deep mechanical growl that promised violence and speed in equal measure. The prototype lifted off with startling authority, its climb rate immediately eclipsing every expectation. Fubashi watched his altimeter unwind as the Hayate Hurricane lived up to its name, clawing skyward at 2780 ft per minute. Below him, Koyama's engineering team scattered across the tarmac, some shouting observations to stenographers, others simply staring upward in wonder. This was the climb rate that could match the Mustang. This was the performance that could change everything. At 15,000 ft, Fubashi leveled off and began his speed runs. The airspeed indicator climbed past 350 mph, then 360, then 370. His heart hammered against his ribs as the needle approached 380. At 387 mph, he eased back on the throttle and keyed his radio. Tadakawa Control maximum level airspeed achieved 387. Repeat, 387 mph. The words felt like victory itself flowing through the radio waves. In the engineering hangar, Koyama heard those numbers and felt 20 years of professional frustration dissolve into pure elation. 387 mph. The American P-51D model achieved 437 mph in optimal conditions, but the 50 megap seemed bridgeable, especially when considering the Ki-84's superior armament. Where the Mustang carried 650 caliber machine guns, the Hayate mounted two 12.7mm machine guns, paired with two devastating 20mm cannons against B-29 bombers. Those cannons would prove decisive. Koyama had designed the Ki-84 to address every weakness that had plagued Japanese fighters since the war began. The legendary Zero had dominated the Pacific's early battles through speed and maneuverability, but American pilots had learned to exploit its fatal flaw: complete absence of pilot protection. The Ki-84 featured 13mm of head and back armor, multiple fuselage bulkheads, and that thick armor glass canopy. Japanese pilots would no longer die from single lucky shots. As Fubashi began his landing approach, the prototype's advanced features revealed themselves in subtle ways. The direct fuel injection system delivered smooth, consistent power throughout the flight envelope. The hydraulic systems responded with mechanical precision. Even the landing gear, a complex assembly that had troubled earlier prototypes, extended and retracted flawlessly. When the main wheels touched down on Tatiawa's runway, Fubashi felt the reassuring bite of effective wheel brakes, a detail that separated professional aircraft from experimental curiosities. The ground crew swarmed the prototype as Fubashi shut down the engine. Mechanics immediately began checking engine temperatures, oil pressure readings, and fuel consumption figures. Their preliminary assessments were extraordinary. The Ha-45 had run cool throughout the test flight, consuming fuel at rates that promised impressive operational range. More importantly, post-flight inspection revealed no mechanical anomalies, no stress fractures, no warning signs of impending failure. In the debriefing room, Fubashi faced a semicircle of engineers, military officials, and production managers, all hanging on his every word. His report was methodical, clinical, and devastating in its implications for American air superiority. Control response: immediate and precise throughout the speed range. Engine performance: consistent power delivery from sea level to 20,000 FT weapon system. All 4 guns fired without malfunction during test bursts. Conclusion: this aircraft meets or exceeds all performance specifications. Factory manager Yamamoto, representing Nakajima's production division, studied the test data with barely concealed excitement. The Imperial Japanese Army Air Force had already placed preliminary orders for over 3,000 Ki-84 fighters, and these test results would certainly trigger additional contracts. His calculators were already determining production schedules, material requirements, and delivery timelines. The war had created unlimited demand for high-performance fighters, and Japan finally possessed a design worthy of that demand. Yet, even in this moment of engineering triumph, subtle warning signs flickered at the edges of consciousness. The Ha-45 engine, for all its power, ran hotter than previous Japanese radials. Ground crews noted that post-flight engine temperatures remained elevated longer than expected, suggesting cooling system limitations that might prove problematic in tropical combat zones. The complex direct injection system, while delivering superior performance, required more precise maintenance than the simple carburetors that powered most Japanese aircraft. Most concerning was the landing gear assembly itself. While it had functioned perfectly during testing, the mechanism was significantly heavier and more complex than previous designs. The hydraulic actuators, precision machine struts, and integrated brake systems represented manufacturing challenges that would stress Japan's industrial capacity as production scaled upward. Koyama's perfectionist engineering had created a masterpiece, but masterpieces demanded master craftsmen to build them. As summer 1943 faded into autumn, the Ki-84 program accelerated toward full production. Test pilots throughout Japan reported similar results. The Hayate consistently outperformed existing Japanese fighters while approaching Mustang-level capabilities. Intelligence reports from the Pacific suggested that American pilots, grown confident through months of aerial dominance, were unprepared for a Japanese fighter that could match their speed and exceed their firepower. The promise seemed absolute. Japan had built a plan to beat the P-51 Mustang. The prototypes proved it. The test data confirmed it. The production orders reflected it. But promises made in engineering laboratories would soon face the brutal realities of wartime manufacturing. And the Hayate's true test would come not in the controlled environment of Tachikawa Airfield, but in the chaos of mass production under an increasingly desperate empire. Squadron leader Kobayashi adjusted his parachute straps as he walked toward his Ki-84 on the dusty airfield outside Hanka, China, in the sweltering heat of August 1944. The 22nd Senti had received their first operational Hayates just 2 weeks earlier, and today would mark their combat debut against American Army Air Force fighters that had grown dangerously confident over Chinese skies. The morning briefing had been electric with anticipation. Finally, Japanese pilots would fly aircraft that could match the enemy's vaunted Mustangs and Thunderbolts. The first combat sorties exceeded every expectation. American pilots, accustomed to easily outrunning Japanese interceptors, found themselves facing fighters that could not only match their speed, but delivered devastating cannon fire from unexpected angles. Lieutenant Sasaki's after-action report captured the Americans' shock. Enemy formations scattered immediately upon visual contact. 2 P-51s attempted high-speed dive escape. Unsuccessful. Both destroyed by 20 mm cannon fire at 400 tier mph indicated airspeed. For 3 weeks, the 22nd Senti K-84s terrorized American formations over central China. The psychological impact was immediate and profound. American bomber crews, who'd grown accustomed to Japanese fighters falling behind during their escape runs, now faced interceptors that could pursue them at maximum speed while delivering accurate fire. The tactical balance that had favored American aviation since 1943 seemed to shift overnight. But Kobayashi noticed troubling patterns emerging from successful missions. Aircraft 1446 returned from a routine patrol with hydraulic fluid streaming from its landing gear bays. The pilot reported normal flight characteristics, but post-flight inspection revealed stress fractures in the main gear struts, fractures that hadn't existed during pre-flight checks. Maintenance Chief Watanabe examined the damaged components with growing concern, noting that the steel appeared brittle, almost crystalline in structure. 3 days later, aircraft 1452 suffered a complete landing gear collapse during touchdown. Pilot Officer Tanaka walked away uninjured, but the Hayate was a totalis. Its fuselage twisted beyond repair, engine mounts cracked, propeller blades bent into useless metal sculptures. The accident report listed mechanical failure as the cause, but Kobayashi's experienced eye detected something more sinister. The quality of materials was inconsistent with the prototypes they had tested in Japan. Watanabe's detailed inspection of the collapsed gear revealed the scope of the problem. The heat treatment of the steel struts was uneven, creating areas of extreme hardness adjacent to sections that remained dangerously soft. Under the stresses of combat maneuvering and heavy landings, these inconsistencies acted like fault lines, spreading fractures through critical load-bearing components. "This is not the same steel quality we saw in the early production aircraft," he reported to Kobayashi. "Something has changed in the manufacturing process." The engine problems proved even more concerning. The Ha-45 Homare that had performed flawlessly in prototypes now exhibited wild power variations from aircraft to aircraft. Lieutenant Yamada's fighter produced barely 1/800 horsepower at takeoff, 200 less than specifications demanded. Sergeant Pilot Ito's engine ran so hot that he was forced to abort 2 missions when cylinder head temperatures exceeded safe limits. Most disturbing was the complete engine failure experienced by Pilot Officer Fuja at 8,000 FT over enemy territory. Only his skill and luck allowed him to glide back to friendly airspace and execute a dead stick landing. Maintenance records revealed the underlying crisis. Engines supposedly built to identical specifications varied by as much as 200 horsepower in actual output. Some Homer engines delivered their rated power smoothly across the entire operational envelope. Others suffered from rough running, overheating, or premature component failure. The precision manufacturing that had created the prototype's exceptional performance was disappearing from production aircraft with alarming speed. By September, operational readiness rates for the 22nd Centi had fallen from 80% to 65%. Aircraft that should have been dominating Chinese skies instead sat grounded, awaiting spare parts that arrived irregularly or not at all. Kobayashi found himself rationing combat missions, carefully selecting which pilots would fly the few aircraft that remained mechanically sound on any given day. The impact on pilot morale was devastating. These men had trained extensively on the promise that the Ki-84 would restore Japanese air superiority. They had memorized performance figures, practiced tactics designed to exploit the Hayate's speed advantage, and psychologically prepared themselves for aerial combat in a fighter that could match American capabilities. Instead, they found themselves flying aircraft that might fail at any moment, often without warning. Pilot Officer Nakamura captured the growing frustration in his personal diary. "Today my engine lost power during combat. With 2 P-40 Warhawks aircraft that I should have easily outrun, nearly shot me down because my Homer could not maintain full power above 12,000 FT. The Americans are not better pilots. They simply have aircraft that work as advertised." Reports from other K-84 squadrons confirmed that the 22nd Centi's problems were not isolated incidents. The 52nd Centi in the Philippines reported similar landing gear failures. The 73rd Centi in Formosa documented identical engine inconsistencies. Factory manager Yamamoto received increasingly urgent requests for technical support, spare parts, and explanations for the declining quality of production aircraft. Intelligence reports from captured American pilots revealed the enemy's growing awareness of Japanese manufacturing problems. A downed P-51 pilot told his interrogators, "We were told to watch for new Japanese fighters with improved performance, but half the ones we encounter seem to have mechanical problems. Some can barely keep up with our bombers, let alone fight our escorts." The statistical reality was undeniable. Combat losses to enemy action remained acceptable. The K-84's armament and protection allowed experienced pilots to engage American fighters on roughly equal terms. But mechanical failures were destroying nearly 30% of the aircraft without any enemy involvement whatsoever. Landing gear collapses, engine failures, hydraulic malfunctions, and brake system breakdowns were removing Hayates from combat more effectively than American guns. Kobayashi's October status report to higher headquarters painted a grim picture. 22nd Senti currently maintains 9 aircraft in operational condition from original complement of 18. Losses 3 to enemy action, 6 to mechanical failure. Request immediate technical assistance and priority delivery of replacement aircraft, built to original specifications. The response from Tokyo was both revealing and terrifying. Replacement aircraft were being produced as rapidly as possible, but quality control standards had been reduced to meet urgent delivery requirements. The perfect fighter that Japan had designed to beat the P-51 Mustang was being destroyed not by American pilots, but by the desperate industrial shortcuts required to build it fast enough for a losing war. The first B-29 superfortresses appeared over Tokyo Bay on November 24, 1944. Their silver fuselages gleaming like deadly angels at $30,000. From his office window at the Nakajima factory in OT, Chief Engineer Koyama watched the formation pass overhead, with the terrible certainty that his world was about to change forever. The bombers flew with impunity too high for most Japanese interceptors, their mere presence announcing that America's industrial might had finally reached Japan's home islands. Factory manager Yamamoto received the acceleration order 3 days later. Ki-84 production must increase from 40 aircraft per month to 120 by January 1945. The directive came with no additional resources, no extra steel allocations, and no supplementary skilled workers. Simply a demand that the impossible be accomplished through determination and sacrifice. Yamamoto stared at the production schedule spread across his desk, performing mental calculations that confirmed what his experience already knew. Quality would be the first casualty of this new urgency. The initial B-29 raids targeted aircraft factories with surgical precision. On February 10, 1945, waves of super fortresses swept over the yacht complex at midday, their bomb bays disorging hundreds of 500 lb general-purpose bombs across the Nakajima production facilities. The explosions shattered assembly lines, destroyed precision tooling, and buried months of accumulated parts inventory under tons of twisted metal and concrete debris. Koyama watched 17 years of engineering excellence disappear in 90 minutes of methodical destruction. 2 weeks later, carrier-based aircraft from Task Force 58 struck the rebuilt portions of the factory in a coordinated attack that demonstrated America's overwhelming air superiority. Hellcats and Corsairs swept in at low altitude, their 50 caliber machine guns stitching lines of destruction across anything that resembled industrial activity. The raids were so frequent and effective that normal production became impossible. Nakajima was forced to implement a dispersal program that scattered Ki-84 manufacturing across dozens of smaller facilities hidden in schools, temples, and underground bunkers. The dispersal strategy reduced production to less than 25% of required output, while simultaneously destroying quality control systems that had barely functioned under normal circumstances. Components manufactured in a converted schoolhouse in Gunma Prefecture arrived at final assembly with dimensional tolerances that varied wildly from specifications engine parts produced in underground. Workshops lacked the precision machining that made the Ha-45 Homare function properly. Most critically, the heat treatment facilities required for proper steel processing were too large and conspicuous to hide from American reconnaissance aircraft. Yamamoto's daily reports documented the cascading collapse of industrial capability. High-grade steel became unavailable as Allied bombings severed transportation networks and destroyed specialized foundries. The complex alloys required for landing gear struts were replaced with whatever metals could be scred from demolished buildings and wrecked vehicles. Quality inspectors, many of whom had been drafted for combat duty, were replaced by elderly volunteers who lacked the technical knowledge to identify substandard components. The fuel crisis compounded every other problem exponentially. The Ha-45 Homare had been designed for high-octane aviation gasoline that provided smooth, consistent combustion across its 18-cylinder configuration. By early 1945, Japanese refineries could produce only low-grade synthetic fuel that caused the complex engine to run rough, overheat, and suffer premature component failures. The carbureted variants of the engine, hastily introduced to simplify maintenance, proved even more troublesome than the original direct injection systems when fed inferior fuel. Lieutenant Fubashi found himself training replacement pilots on aircraft he no longer recognized as the fighters he had tested 18 months earlier. The Ki-84 prototypes that had achieved 397 MPAs in controlled conditions were now being delivered from factories with maximum speeds barely exceeding 250 meters. Engine power output varied so dramatically that pilots could not predict their aircraft's performance from one flight to the next. The human cost of industrial collapse became visible in accident reports that filled Fubashi's desk daily. Pilot Officer Sato was killed when his landing gear collapsed during a routine training flight, struts snapping without warning due to improper heat treatment. Lieutenant Yoshida survived his forced landing after complete engine failure, but the aircraft was destroyed when inadequate brake systems could not stop the powerless fighter before it hit a drainage ditch. Most heartbreaking was Flight Sergeant Kimura, who died in a crash caused by control surface failure. A catastrophic breakdown that investigation revealed was due to substandard bolts that had been manufactured from scrap metal in a basement workshop. Production statistics told the story of an industrial system in terminal collapse. The original Ki-84 specifications called for 3,000 Iron 14 aircraft to be delivered by war's end. By spring 1945, fewer than 2,800 had been completed, and operational readiness rates for delivered aircraft had fallen below 45%. American intelligence estimates suggested that Japanese fighter production was actually accelerating, but they failed to account for the quality degradation that made newly manufactured aircraft effectively useless for combat operations. The submarine blockade that surrounded Japan's home islands prevented delivery of critical components that could not be manufactured domestically. Specialized instruments, precision bearings, and high-quality steel all required materials or manufacturing techniques that Japan no longer possessed. Ki-84 fighters rolled off assembly lines missing essential equipment or fitted with substitutes that rendered them dangerous to their own pilots. Squadron leader Kobayashi, temporarily reassigned to train new pilots at Kasumigara Air Base, watched waves of replacement. Aviators struggle with aircraft that bore little resemblance to the fighters they had been promised. Young men who had dedicated months to mastering Ki-84 performance characteristics found themselves flying machines that responded unpredictably, failed mechanically without warning, and could barely outrun the American bombers they were supposed to intercept. Underground factories represented Japan's final desperate attempt to maintain aircraft production. Elaborate tunnel complexes carved into mountainsides housed assembly lines designed to produce 200 Ki-84 fighters per month, while remaining invisible to American reconnaissance. But the underground facilities lacked proper ventilation for paint booths, adequate lighting for precision work, and transportation infrastructure for moving completed aircraft to operational airfields. Most critically, they could not replicate the quality control systems that had made the original prototypes exceptional fighters. By April 1945, the gap between design potential and manufacturing reality had become an unbridgeable chasm. The same aircraft that had promised to restore Japanese air superiority was now more dangerous to its pilots than to the enemy. Factory manager Yamamoto's production reports documented an industrial tragedy. Japan possessed the engineering knowledge to build world-class fighters, but had lost the manufacturing capability to produce them reliably. The perfect storm of Allied bombing, material shortages, and desperate production quotas had transformed the Ki-84 from Japan's greatest aviation achievement into a symbol of industrial collapse. The invasion of Okinawa began at dawn on April 1, 1945, and within hours, the desperate reality of Japan's position became undeniable. American forces had established a foothold just 350 miles from Kyushu, close enough that their fighters could escort bombers to any target in the Japanese home islands. Squadron leader Kobayashi received orders that afternoon to prepare 11 Ki-84 fighters for a suicide mission against the American airfields being carved out of Okinawan coral, a mission that would require his aircraft to function flawlessly over the longest overwater flight most of his pilots had ever attempted. The pre-flight preparations revealed the full extent of the manufacturing crisis that had consumed Japanese aviation. Aircraft 1463 showed hydraulic fluid leaks from multiple system connections, the result of gaskets manufactured from inferior rubber compounds that could not maintain pressure under combat stress. The port landing gear on aircraft 1471 extended only partially during testing. its actuating mechanism binding due to poor quality machining tolerances in the hydraulic cylinders. Most concerning was aircraft 1458, whose Ha-45 engine produced black smoke during run-up, indicating internal damage that maintenance crews lacked the parts to repair. Maintenance Chief Watanabe worked through the night attempting to configure 11 airworthy fighters from the 18 aircraft theoretically assigned to the squadron. His repair efforts resembled battlefield surgery more than precision maintenance, cannibalizing serviceable components from unflammable aircraft to create machines that might survive a single combat mission. The fuel pumps removed from aircraft 1444 were installed in aircraft 1467. The landing gear struts from aircraft 1455 replaced the cracked assemblies in aircraft 1473. By April 14th, Watanabe had assembled what he grimly described as 11 aircraft built from the bones of 18. The mission briefing on April 15th revealed the tactical impossibility facing Japanese aviation. Intelligence reports indicated that American forces had established 3 operational airfields on Okinawa, defended by over 200 fighter aircraft, including the latest P-51D models and P-47 Thunderbolts. Kobayashi's 11 Ki-84 fighters would approach at low altitude to avoid radar detection, climb to attack altitude over the target, deliver their bombs against parked aircraft and fuel dumps, then attempt to fight their way back to Kyushu through what would certainly be overwhelming fighter opposition. The mission launched at 0530 hours with Kobayashi leading the formation in aircraft 1469, one of the few Hayates that still demonstrated performance approaching original specifications. The flight proceeded normally for the first hour, 11 fighters maintaining tight formation as they skimmed the wave tops at 50 ft altitude. But the mechanical failures that had plagued Ki-84 operations throughout 1945 began manifesting before the formation even reached enemy territory. Aircraft 1472, flown by Pilot Officer Sasaki, began trailing white smoke at 0645 hours as its engine started consuming oil at an alarming rate. The Homare cylinder head temperatures climbed steadily into the red zone, despite Sasaki's attempts to reduce power settings and lean the fuel mixture. 20 minutes later, the engine seized completely, its internal components welding themselves together from excessive heat and inadequate lubrication. Sasaki had no choice but to attempt a water landing, becoming the first casualty of a mission that hadn't yet encountered enemy resistance. The formation continued toward Okinawa with 10 aircraft, but additional mechanical problems emerged as the flight progressed. Lieutenant Tanaka reported intermittent loss of hydraulic pressure in aircraft 1468, making his flight controls increasingly heavy and unresponsive. The fuel flow indicator in aircraft 1471 fluctuated wildly, suggesting pump failure or contaminated fuel lines that might starve the engine at any moment. Most ominously, aircraft 1465 began experiencing electrical failures that gradually eliminated radio communication, navigation instruments, and engine monitoring systems. As their remaining formation approached the Okinawan coast at 0715 hours, American radar operators detected the low-flying aircraft and vetoed interceptors to meet them. The tactical situation deteriorated rapidly as P-51 Mustangs dove from superior altitude to engage the Japanese fighters before they could reach their targets. Kobayashi ordered maximum power and began climbing to gain the altitude necessary for bombing runs, but several of his aircraft could not respond to the emergency power settings. Aircraft 1464, flown by Flight Sergeant Watanabe, suffered complete engine failure during the maximum power climb, when its Homer's connecting rod broke and punched through the crankcase. The catastrophic internal damage instantly converted the engine into a source of drag rather than power, forcing Watanabe to attempt a dead-stick landing on the contested island below. Aircraft 1467 experienced landing gear extension during the combat climb, a hydraulic malfunction that increased drag so dramatically that the fighter could not maintain formation air speed. The actual attack against American airfields became a chaotic running battle, as mechanical failures reduced Japanese combat effectiveness more than enemy action. Lieutenant Yoshida successfully dropped his bombs on a fuel dump, but was forced to break off his strafing run when his 20mm cannons jammed due to faulty ammunition feed mechanisms. Pilot Officer Nakamura's aircraft lost all hydraulic pressure during his bombing run, making the controls so heavy that he could barely maintain level flight, let alone engage in combat maneuvering. The withdrawal from Okinawa became a desperate race for survival as American fighters pursued the surviving Japanese aircraft back toward Kyushu. Aircraft 1473 suffered brake system failure during its escape attempt, causing the wheel assemblies to lock and creating massive drag that made the fighter an easy target for pursuing Mustangs. The electrical failures in aircraft 1465 finally caused complete instrument failure, forcing the pilot to navigate by dead reckoning while under attack from multiple enemy fighters. Of the 11 Ki-84 fighters that launched the mission, only 3 returned to base, and 2 of those suffered landing gear collapses during touchdown due to the inferior steel and inadequate heat treatment that had become standard in late war production. The mission's tactical results were negligible, minimal damage to American airfields that were repaired within hours, while the strategic implications were devastating. Japan's most advanced fighter aircraft had proven incapable of executing even basic combat operations due to mechanical unreliability. Kobayashi's after-action report captured the complete breakdown of Japanese aviation capability. Mission effectiveness reduced to 0 due to mechanical failures exceeding combat losses by ratio of 2.1. Aircraft that reached target area could not maintain formation or execute coordinated attacks due to individual system failures. Recommendation: suspend all Ki-84 combat operations until manufacturing quality control can be restored to acceptable standards. The anonymous pilot diary entry found in aircraft 1469 after the mission revealed the human cost of industrial collapse. Today I flew what was supposed to be Japan's best fighter. The engine coughed at $15,000. The landing gear warning light flickered continuously throughout the flight. When I landed, the left strut folded immediately upon touchdown. This is not the plane that was promised to us in training. This is not the weapon that will save Japan. The atomic bomb that destroyed Hiroshima on August 6, 1945 vaporized not just a city, but the final illusions of Japanese resistance. In the underground aircraft factories carved into mountainsides around Nagoya, workers continued assembling Ki-84 fighters with components so substandard that finished aircraft could barely taxi, let alone fly combat missions. Factory manager Yamamoto walked through tunnels lined with partially completed Hayates whose engines would never start, whose landing gear would collapse on first use, whose control surfaces had been manufactured from materials salvaged from bombed buildings. The planned production rate of 200 aircraft per month had become a cruel fantasy. Underground assembly lines produced perhaps 30 fighters monthly, and half of those were immediately grounded due to mechanical failures discovered during initial engine runs. The precision tooling required for Ha-45 Homare engines had been destroyed in bombing raids months earlier, replaced by improvised equipment that could not maintain the tolerances necessary for reliable operation. Workers who had once crafted components to thousandth of an inch now struggled to achieve dimensional accuracy, measured in fractions of inches. Chief Engineer Koyama received reports from test facilities that documented the complete collapse of Ki-84 performance late production aircraft that were theoretically identical to the prototypes of 1943 now achieved maximum speeds below 250 mph, slower than the American P-40 Warhawk fighters that had been obsolescent since 1942. The Homare engines produced such inconsistent power that pilots could not predict whether their aircraft would climb normally or struggle to maintain altitude even in level flight. Lieutenant Fubashi found himself conducting acceptance flights on aircraft that bore only superficial resemblance to the fighters he had tested 2 years earlier. The cockpit instruments were crude substitutes for the precision gauges originally specified, often providing readings so inaccurate that pilots flew by intuition rather than data. The hydraulic systems leaked constantly, leaving pools of fluid on hangar floors and creating slippery conditions that made ground operations hazardous. Most tragically, the armament systems that had made the Ki-84 potentially superior to American fighters now jammed regularly due to ammunition manufactured from inferior materials in makeshift factories. The fuel situation became catastrophically worse as Japan's synthetic refineries suffered repeated bombing attacks. The high-octane aviation gasoline that allowed the Homare engine to produce its rated 2,000 horsepower was replaced by crude substitutes that caused severe engine knock, overheating, and premature component failure. Pilots reported that their engines lost power unpredictably during flight, sometimes recovering after several minutes, but often forcing emergency landings that usually resulted in landing gear collapse due to the brittle steel used in late war struts. Squadron leader Kobayashi, now assigned to defend the Tokyo area with whatever aircraft could be made airworthy, faced the impossible task of intercepting B-29 bombers with fighters that could barely reach the altitudes where superfortresses operated. His pilots, many of them teenagers with less than 50 hours of flight training, struggled to control aircraft whose flight characteristics changed from day to day, depending on which components had been replaced with substandard substitutes during maintenance. The mechanical failure rate reached catastrophic levels by July 1945. Over 50% of Ki-84 fighters were grounded at any given time, awaiting parts that would never arrive or repairs that could not be completed with available materials. Aircraft that did manage to take off faced a 20% probability of suffering critical system failures during flight. Failures that often prove fatal to pilots who lack the experience to handle emergencies. An aircraft whose backup systems had also been compromised by poor manufacturing quality. The arrival of American technical personnel in Japan following the surrender revealed the full extent of the engineering tragedy that had befallen the Ki-84 program. Captain Chuck Morrison, a test pilot assigned to evaluate captured Japanese aircraft, approached the examination of a late production Hayate with thematical professionalism that characterized American technical intelligence efforts. His initial assessment, based purely on visual inspection, noted numerous manufacturing defects that would have been rejected immediately in American production facilities. Morrison's flight test of the captured Ki-84 using high-octane American aviation fuel produced results that stunned both American and Japanese observers. With proper fuel and basic maintenance to correct the most obvious mechanical problems, the fighter achieved a maximum speed of 426 mph within 11 mph of the P-51 Mustang's top speed. The climb rate improved dramatically to over 3,000 ft per minute. Most remarkably, all systems functioned as originally designed when provided with quality components and proper maintenance procedures. The post-war revelation was devastating in its implications. Japan had indeed designed a fighter capable of matching or exceeding American aircraft performance. The Ki-84's fundamental engineering was sound, its aerodynamics were efficient, and its power plant was potentially superior to anything America produced when properly manufactured and maintained. The failure was not conceptual but industrial. Japan's manufacturing capacity had collapsed under the pressure of total war, making it impossible to build the aircraft their engineers had designed. Fubashi witnessed Morrison's test flights with emotions that mixed professional admiration with profound grief. The American pilot was flying the Ki-84 exactly as Fubashi had flown the prototypes in 1943. Smooth power delivery, responsive controls, and performance that justified the optimism that had once surrounded the program. "We had the right design," Fubashi reflected as he watched Morrison demonstrate the fighter's capabilities. "We just couldn't build it when it mattered most." The statistical analysis conducted by American technical teams revealed the scope of the industrial catastrophe. Of 3,514 Ki-84 fighters produced during the war, fewer than 120 had achieved acceptable operational status at any given time. Combat losses to mechanical failure exceeded combat losses to enemy action by nearly 2-to-1. The aircraft that should have restored Japanese air superiority instead became a symbol of industrial collapse under the pressures of total war. Factory manager Yamamoto, interviewed by American investigators, provided insight into the cascading failures that had destroyed Ki-84 production quality. The bombing of precision tooling facilities, the loss of skilled workers to combat units, the substitution of inferior materials, and the impossible production quotas had combined to create a perfect storm of manufacturing problems. "We knew we were building defective aircraft," he admitted, but the alternative was building no aircraft at all. The single Ki-84 that survived the war intact became a monument to engineering excellence destroyed by industrial limitations. Displayed at the Toko Heiwa-Kinenkan Museum at Chiran, the preserved fighter represents both the pinnacle of Japanese aviation, design, and the tragic consequences of attempting to mass-produce precision aircraft under impossible wartime conditions. Museum visitors unaware of the fighter's complex history see only a sleek aircraft that appears capable of challenging any fighter of its era, which under the right circumstances it absolutely was. The Ki-84 story became the definitive case study of the difference between engineering brilliance and manufacturing capability. Japan's engineers had created a fighter that could beat the P-51 Mustang. Their industrial system, crushed under the weight of total war, proved incapable of building that fighter when the nation needed it.